Resume recording. Okay, good afternoon, class. Thank you for attending the synchronous session. No? Lupit. Konti na lang tayo. Pagod na tayong lahat. Okay, so ang next topic natin will be on chapter 4. And so far, we've been dealing with an ensemble of charges. Then, next is yung conductor. Pinag-anaral natin yung conductor. So now, ang aaralin natin is what is the electric field in matter, in general matter, no? It's just not, yung una kasi, it's a compilation ng isang type of charge lang, Q, which is can be positive or negative. Then, yung next natin na sinubukan is yung conductor, which is walang charge sa loob. Ngayon, however, i-aaralin na natin yung matter na mismo. So yung matter na mismo, ito yung mga molecules natin, meron silang positive na nucleus, then some electron cloud na negative, syempre. Okay? So they're both positive and negative. Okay? Okay. Now, let's rename our insulators with a fancy term. So dielectrics. Dielectrics. Okay? Para kasi ang pangit kasi ng insulator kasi parang ini-assume na natin, walang electric field sa loob niya. But no, it has electric fields, okay? Nakakadalo yung kuryente sa insulators natin. But it's not, hindi lang siya ganun ka-effective as compared to your conductors, of course. Now, ang itatackle natin yan is polarization, okay? So whenever an electric field interacts with matter, so yung mga molecules mo can either spin, or stretch. Okay? Okay. Okay. So, kuwari, meron kang some molecule with a positive nucleus, then an electron cloud na circular. Spherical, syempre. Okay? Now, what happens if you bombard it with an electric field? Okay? So, let's say we have an electric field that's going like this. So, ang mangyayari is yung positive na charges susunod sa electric field, and then yung negative charges mo lalayo sa electric field, di ba? So, in essence, magiging ganito siya. Okay? Pansinin niyo na nausog sa kanan yung positive nucleus, then yung electron cloud umusog pa left. Okay? Ayun, pansinin niyo. Okay? So what happens if binombard ko ng electricity itong molecule ko. Tapos at some time pinatay ko yung electric field ko. Mangyayari, babalik siya sa normal state niya. However, if the electric field is strong enough, ang mangyayari is itong bagay mong to, hindi na siya babalik sa original state niya. It becomes dipoles. Okay? It becomes a dipole. Okay? So when that happens, let's say, itsura niya will be something like this. Okay? Kasi para siyang dipole na positive dito and then negative. Okay? Okay. So para siyang dumbbell. Dumbbell na siya ngayon. Okay? So when that happens, yung dipole mo, the dipole moment, P, becomes a function of the electric field na binobombard sa kanya. Okay? And then for yung A, yung alpha dito, is the atomic polarizability, which is of course different for every material. Okay? Iba yan sa iba't ibang metals, etc. etc. Hydrogen gas, ganun. So, may mga different values yan. Alright? Okay. Now, so ganun ang galing, no? Pag binombard mo yung pinolarize mo. Okay, pinolarize mo na siya. Ibig sabihin, meron kang poles. Ang mangyayari, kokopyahin nung dipole mo, yung electric field, scaled nga lang with some constant alpha. Okay? So that's stretching, no? Parang i-stretch natin yung positive, then yung negative papalayo sa isa't isa. Okay? Now, what else can we understand about this system whenever we have molecules? Okay, whenever we have molecules, may positive, may negative, tingnan naman natin ngayon paano pag hindi sila naka-align with the field, okay? Or hindi mo sila ma-stretch. Mangyayari, magkakaroon ka ng torque. Okay? So, let's write that down. Let's try to solve things. And, di ba, ang torque mo is just R cross F. Okay? But in this case, meron kang R plus cross F plus. And then, of course, i-add natin yan sa R minus cross F minus. Okay? And then, yung R plus mo will be just D over 2. And then, cross natin to. D over 2. Then, ang F plus mo will be positive Q, E. Okay? And then, add natin siya sa D over 2 ulit. Tapos, negative D over 2. Okay? Kasi pabaliktad yung direction niya. Cross, of course, negative Q. And then E. Okay? Let me check that down. Check ko lang. Okay, tama na. Okay? Okay, and then we simplify this guy. So magka-cancel lang yung negative signs to, no? And then in essence, this is just QD. QD. 1/2, di ba? So 1/2, mag-add lang sila. Tama ba? In essence, QD cross E. Okay? And what is QD? Kung maalala nyo, that is the dipole moment times the electric field. Okay? So that happens, no? Kapag tinutukan mo yung hindi naka-align na polar molecule, mangyayari, magro-rotate siya, iikot siya. Okay, and the torque is given by P cross E. All right? Okay. However, sometimes yung field mo, it's not uniform. Bale, yung nakaka-apekto sa Q is different from the other side. Okay? So, yung F mo will be different. Okay? So, we have this, okay, F plus. So, yung force acting on the positive charge, then yung force acting on the negative charge. Okay. So, i-add mo yun ngayon. Tapos, different yung fields nila, di ba? Okay. So, E plus minus E minus. So, yung magkaiba ng direction to, guys, lagi, di ba? Pansin nyo dito, negative yung F natin. Okay. Dito, positive F. So, kaya siya negative dito. Okay? So, when that happens, there's a delta E that is produced. So, the difference between the different fields acting on the two charges. Okay? So sa first chapter, meron tayong infinitesimal infinitesimal variable E, and that is defined as joke, which is equal to something like this dotted with some length. Okay? Okay, so from chapter 1, may ganito ka. So we can transform this into something like, hindi na siya infinitesimal, no? Palit tayong color para kaya yung palit ng color. So, dito, ang nangyari lang is dinefine na to as something that is no longer infinitesimal. So, papalitan mo rin yung other side na infinitesimal, which is, of course, some distance d na lang. Okay, so that's that. And then, in all directions, magpapalit ka lang ng variables, and you can see that yung f mo, diba, q, this is just q, and then ayun yung sumunod. Wait lang. Yeah. Yan. Okay. Si delta E plug-in lang natin. Delta E. Del E pala, sorry. Ayan. And then, started with E. Okay. And this is just the E. Pasok ko lang si P, si Q. Started with Q, B. And I know that this is your dipole moment. All right. And pwede mo naman iusog yung ilipat yung dot product. So ito yung lalabas. So ayun yung force mo kapag non-uniform yung field. So may additional forces ka, no? So yung torque pa rin, ganun pa rin. Ganun pa rin siya kukumputin. Okay? Pero may additional forces ka na magaganap. So uusog yung buong molecule mo. Okay? Okay. Okay, so meron tayong again, meron tayong stretching tsaka spinning. So yung spinning is yung alignment. Yung stretching yung nagiging dipole. Okay. What we want to do, of course, is to calculate the electric field or the potential in matter. So let's for now, let's define a variable P, capital P, which is the dipole moment per unit volume. Okay? Let's do that. Now, we want to know the potential due to a dipole. And that is given from last topic, di ba? Nag-ano tayo, multiple expansion. Tapos kinuha natin sa dipole. And we actually arrived at this conclusion. Okay? What is P? Small p is dipole moment. Capital P is dipole moment. Dipole moment per volume. Okay? So thus, pag in-integrate mo ngayon si P, capital P, with respect to a volume, it actually reduces to this. Tama? Kasi Pi, dipole moment per volume, then integrate mo with respect to a volume, magka-cancel yung volume, magiging dipole moment na siya. Okay? Okay. Now, why are we doing that? Okay, let's see. Tingnan natin bakit natin ginagawa yan. Okay. So, ngayon, tingnan natin itong r hat, yung curly r hat over r squared. Curly r hat Okay, r squared. Ngayon, alam natin na kapag kinuha natin yung gradient ng 1 over r, it's just magiging r hat over r squared, curly r's. Okay? So, okay, kung di kayo convinced na ito yun, isipin nyo ito ay potential. Di ba ganyan lagi yung itsura ng potential? Okay? 1 over r yung potential, di ba? Tapos pag ginradient mo yun, makukuha mo yung electric field, which is usually this guy. Okay? So, r hat over r squared. Okay? So, make sense, di ba? Kung hindi kayo convinced. Pero pwede nyo naman i-derive. No? Wala namang problema din kung i-derive nyo on your own. Okay? So, with that, gamitin natin itong fact na to. So, relation na to use it there. Okay? So, when you plug in this thing over there, makakuha natin yung P dotted with this gradient. Okay? With this gradient. Okay. With this, P dotted with the gradient of some scalar function 1 over r, meron tayong P dotted with... So, yung prime dito, ibig sabihin prime coordinates yung either derivative mo. Okay? Kasi nasa prime coordinate yung integral natin. Okay? Tapos yung r hat, yung polarization mo, P, is of course directed in the position of the charges, r prime. So dapat yung dot mo sa kanya is prime coordinates din. Okay? Dito, di ba? Okay, now we go back. So, okay. We have this. Ito yung loob ng integral, di ba? Ngayon, gagamit ako ng product rule. Okay? Nasa likod ng libro. Sa number 5, sa likod ng libro. This is it. This is it, pansit. Okay, hanapin ko ngayon tong itsurang ito dito sa number 5 natin. Okay, papansin ko that this could be A dotted with some gradient of scalar function f, which is yung 1 over r natin. Okay? So with that, this is actually equal to del dotted with del prime dotted with the scalar function times a. Yung a natin dito will be p. So that is dotted with p over r. Tama. P dotted with del dotted with p over r, sorry. And then I have to minus this para malipat ko sa kabila. Okay. Copying ko lang. So the scalar function is outside. So we have 1 over r. Then I have to get the divergence of p. Lagyan natin ito ng ganun. Okay? Okay. I now plug in this guy. This whole thing. The right-hand side. Plug-in ko siya dito. So the potential has to be V over 1 over 4 pi epsilon naught. Tapos integral volume integral ng del dotted P d tau minus volume integral pa rin del dotted P d tau. Okay? Okay. Now I use, joke, hindi ko pa nasarado. Yan. Okay. Now, tingnan ko yung first term ko. I can use the divergence theorem. The divergence theorem is given by this. So basically, magiging surface integral na lang siya. Okay? Surface integral ng A dotted with dA. So P, capital P, dotted with dA. Okay? Over R. The other term is, wala lang, ganun pa rin siya. Del dotted P over R beta. Okay? Fairly simple. Okay, now it's beautiful. Okay. Tingnan niyo yung tingnan niyo yung surface tingnan niyo yung similarities ng dalawang term. Naka 1 over R sila parehas. Okay, with some terms on the numerator. Okay. So ito 'yun, no? Ayan yun. Para hindi tayo malito. Ito ay prime pa rin. Sorry, hindi ko nalagay. Prime pa rin, of course. Yung mga integral prime din. Ayan. Nilagyan ko lang ng prime. Okay, now, ang gagawin natin is to write this down as some sigma. So, si P dotted with dA, dA prime, okay, hindi ko nalagay yung prime. Pwede ko siyang isulat as sigma B, okay? Sigma B, P dotted with, capital P dotted with n hat. So, yung n hat yun nandun sa kasama ng dA mo, di ba? Kasi yung dA na infinitesimal surface area is always like this, dA times n hat. Diba? So, hiniwalay lang. Okay? So, let's write that down as sigma B. And that's that guy. dA na lang. Hindi na siya vector over R. So, that's your first term. And then the second term will be, sulat natin yung numerator as sigma, rho B, rho sub B. Tapos, i-define natin yung rho na yan as negative. Kukunin natin yung negative doon. Del dotted with P. Okay? Okay. So bakit bakit B? Okay. So itong mga B na to, tinatawag natin silang bound charges. Bound, so nakadikit sa kanila. Okay, explain natin yung mamaya. Pero gamitin muna natin the equation na to, no? So para maintindihan natin kung paano siya ginagamit. Okay? So basically your potential whenever there's a dielectric in the system that is polarized. Okay, P, may polarization ka. Ang potential mo will be just the two integrals. Volume integral ng rho d tau over R and then surface integral ng sigma dA over R. Very simple. Okay? Okay, let's try an example. So find the electric field produced by a uniformly polarized sphere of radius R. So meron kang sphere na spherical na material that is uniformly polarized. Ano ibig sabihin nun? So, isang direction lang siya, no? Okay? So, uniformly polarized. Now, isang direction lang siya. What I can do is, i-align ko na lang yung eco with respect to z-axis. Okay? Pwede kong gawin yun. Pwede rin x-axis, pwede rin y-axis. Okay? Walang problema kung anong gusto niyo trip niyo sa buhay. Pero ang trip ko ngayon is tatapat natin siya sa z-axis. Bakit? Mas madali kunin yung mga dot product. Kasi may theta ka na, which is your usual theta in the spherical coordinate. Okay, let's solve this. Solve muna natin itong sigma B and rho B bago tayo proceed in getting the potential. Tama, di ba? Okay, systematic lang tayo. So sigma B is just P, capital P, dotted with n hat. Okay? Now, si P ko, sabi ko, i-align ko siya sa z-axis. So, this is actually just P, z hat. And your dot product with n. Ano yung surface mo? Sphere. Okay? So, yung n hat mo will be radial. R hat. Now, this is very easy. Si P ay constant lang kasi uniform daw yung polarization niya. Okay? So, walang mangyayari dyan. Okay. T. Now, I know R hat dotted with Z hat. That is just cosine theta. Okay? Kaya ako siya pinili na ganun. Kaya ako siya tinutok sa Z para madali yung kunin yung dot product. Okay? Amazing, di ba? Okay. Now, I'll find rho. What is rho B? Okay. Since we know P is constant, the derivative of P must be 0. So that is 0. Okay. Now I can write my potential. Very systematic lang. R 1/4 pi epsilon naught as integral of some surface, close natin, and sigma, I plug in my sigma, which is P cosine theta. P cosine theta over R dA. Okay, alam natin yung dA will transform later on. Joke. Alam natin na mag-transform lang yun sa R squared sine theta d theta dphi. Okay? Okay. So, okay. Sige, magtatanong tayo para practice to. So, medyo practice to sa exam. Eliza, are you there?
Yes po, sir.
Okay. Anong sa tingin mo, paano mo isosolve tong problem na to? Anong atake yung gagawin mo? Will you proceed sa integration?
Di po ako sure, sir, pero magagamit po ba siya yung Gauss law?
Okay. Magagamit ba natin ang Gauss's law?
Pag gumamit po ng sphere.
Okay. Kasi pag nag-Gauss's law tayo, hindi kasi uniform yung field lines, di ba? Yung field lines mo parang pataas siya. Kasi may polarization ka na pataas. Okay, parang mahirap yun, no? Kasi kailangan mo perpendicular lahat ng field lines mo to the Gaussian surface para magamit yung Gauss's law. Parang mahirap pa tayo. Okay, nice try. Okay lang yun, no? Pag nagtatry tayo ng mga bagay-bagay. That's okay. Okay, so parang hindi gagana kasi may polarization tayong pataas. So yung field mo parang pataas lang siya. Okay? So parang pataas lang yung field mo nito. Nakakalito. Okay. May nakakaisip ba kung paano na yun? Sino mag-integrate dito? Madali lang to integrate eh. Sino mag-integrate dito? Taas kamay. Pag nakita ng problem na ganito. Raise your hand kung mag-integrate kayo. Ako, wala nagre-raise ng hand. So, anong gagawin nyo? Lance? Anong gagawin mo, Lance, para ma-solve to?
Hindi ko sure, sir, pero pwede bang ilabas na lang yung P over curly R, tas yung cosine theta integrate?
Okay. So, yun natin Siyempre, pwede natin ilabas yung P dahil constant siya. Okay, cosine theta. However, your R is R squared plus r prime squared minus 2r prime prime cosine theta. Ayan yung itsura ng r natin. Di ba? Tapos lalagay mo pa itong nasa taas. Okay. Actually, r prime mga r, capital R yan. Kasi nasa surface ka lang. Okay, parang mahirap ata ito, do. So, may nakakaisip ba ako anong gagawin? Well, pwede nga kayo mag-integrate. Pwede nyo naman i-solve ito, no? Pwede nyo i-solve yan. Pero, ang gagawin natin, Charan, separation of variables. Okay, so watch closely. Tingnan natin gaano kadali ito pag separation of variables lang. Okay, I suppose my solution can be written as sum of a function of r and a function of theta. Okay? Sige, sulat natin. Okay. Sulat tayo. Let's say v r theta. Okay, practice na rin to sa exam, no? Sum L, running from 0 to infinity. Tapos AL plus BL, RL plus 1, R raised to L. Tama, di ba? Check natin. R raised to L, L plus 1. Tapos PL cosine theta. So yung P dito nakakalito kasi ito ay Lagrange polynomial. So the normal capital P is Lagrange polynomial. Pag may sub na value, that is your Lagrange polynomial. Okay, so we have this solution. Okay? Siyempre, maghahati tayo ng solution natin. There will be a case that is for greater than the sphere. Okay? So, for this case, V out, lagay natin V out. Outside, ibig sabihin. Alam ko na mag-zero agad yung A outside. Okay? Kasi, pag nag-extend ako sa infinity, dapat mag-zero out yung solution ko. Okay, naalala niyo ba yung prosesong yun last time? Okay, so V out will be BL over R, L plus 1, PL, cosine theta. Okay. And then V in, R theta, will be of course the other side. Saan po galing yung solution na yan? Aling solution? Ito? Ito. Tama ba? Ito ba? Okay. Saan galing itong solution na to? Balikan natin. Lecture 11. Naalala nyo, nag-eyeball tayo? Naalala nyo? Okay. Ayan. The general solution kapag ginawa mo yung spherical na separation of variables. Hala, nakalimutan na. Mag-exam na kayo bukas. Okay, so ito yung general solution. Okay? Okay, bakit ko ito pwedeng gamitin? Kasi meron kang azimuthal symmetry. Ibig sabihin, walang phi dependence yung system mo. Okay, that's why we use this. Okay, so that's why we use this. Kasi alam natin, R at theta lang yung dependence ng system natin. Okay? So that's the general solution for your separation of variables. Now, hindi ko na kailangan gawin ulit yung proseso na maglalagay ka ng V, R theta, Laplace equation, etc., etc. Sulat mo pa siya as some function of R, theta, capital ng theta. Ito. Yan. Ganyan, di ba? Yan yung separation of variables. Okay? So, I don't need to do that kasi alam ko naman yung general solution mo. Okay? So, ito na yung general solution mo. Dito. Okay. So, let's continue. So, nasa lesson 11 yun or 12 ba yun? Okay. Previous pa yun. Nandun yung bakit isang hinugot to. Okay? Sa inside, alam natin na dapat kapag 0, hindi magbo-blow up yung sagot mo. So, ito lang yung magsusurvive. Si AL, RL. Okay. So, AL, RL, TL, cosine theta. Okay? Okay. Nice. Okay. So, may 2 solutions ka na. Kailangan mo gawin ngayon is kailangan mo ma-solve si AL at BL. Okay? Now, okay. I know that the solution must be continuous. Okay? So, V in at capital R theta and V out at R theta must be equal. Okay? Saan nanggaling to? Boundary conditions. Okay? From last chapter. Chapter 2. Somewhere there. Okay. I know that these guys are equal. Oops, may nawawala. Summations, of course. Kailangan sum lahat nito. Okay? Okay, so we write this guys down. Practice na rin natin ito sa exam. Okay, PL cosine theta. That is the argument of the Legendre polynomial. Then this is equal to the outside, which is BL over R raised to L plus 1. Now, PL cosine theta. Okay. Kita naman, no? So, I know agad na A, L, R, L must be, oops, sir, anong ginagawa mo? Dapat capital R yan, di ba? Capital R, capital R. Kasi at the boundaries tayo, dapat continuous ang solution. B, L, R, L plus 1. Okay, so AL must be equal to BL R 2L plus 1. Tama? Tama. Okay. Wala magulo doon, di ba? Okay. Now, another boundary condition gagamitin natin, which is the discontinuity between the outside and the inside, at of course R is equal to R, must be equal to the sigma over epsilon. Okay, alam natin yung sigma natin, which is P cosine theta. Easy. Okay, so let's go. Let's do that. Let's do that. So partial of, so let's get the derivative first. Partial of V in with respect to R, tsaka partial of V out. Oops, nasa yung V out? So this is V out. Sa taas pala. Partial of V out with respect to R, of course. Okay. So ang tatablan lang ng derivative ko will be this guy and this guy. Si PL wala naman yan kasi puro cosine theta lang yan tsaka constants. So tatagos lang yan. Okay? Okay. So my this guy is actually L0 infinity and then L0 infinity. Copying ko lang muna yung mga constants, yung mga summation and etc. So BL, ano yung derivative ng ang derivative nito ay taas na lang natin para hindi nakakalito. So this is negative L minus 1. Mas mababawasan pa ng isa. Okay. So this is RL plus 2. Tapos negative L, negative 1. Okay? Tapos PL. Okay, so gagawin nyo to sa exam. May separation of variables sa exam. So ano po yung lower limit ng summation? L0. Oo, L0. Okay. Next ko will be AL. Tapos R L. Tapos bababa lang yung L. So magkakaroon ka ng L, malaking L. RL minus 1. Tama? Tama naman yung pagkakaderivative, di ba? Tama ba? Minsan talaga ganun eh. Kahit mag 1 plus 1 ka nga lang, minsan nagtataka ka ba, 2 ba talaga to? Okay. Okay, so we have this. Now we do the boundary conditions, which is subtracting those two and evaluating at R is equal to capital R. Okay, and that is all equal to negative sigma over epsilon. Okay. So out minus in, di ba? So B, L, negative L, at of course capital R is 2 minus AL, L must be equal to capital R, L minus 1, PL, cosine theta. Okay, and then the summation, of course, huwag natin kalimutan. And this is all equal to sigma, which is negative sigma, which is negative P cosine theta. Ibang pito polarization yan over epsilon naught. Okay? Siyempre, we can write BL in terms of AL. Ay, baliktad pala ako. So, BL is equal to AL R raised to 2L plus 1. Okay? So, I write that down. BLI AL R raised to 2L plus 1. 2L, 1 over R raised to L plus 2 minus AL ups Amazing. Ito pa lang notes ko para sure tayo sa ginagawa natin yung live. Okay. So that's equal to p cosine theta negative. Okay. Okay, so we'll simplify this. Okay. So this is just so this guy, sulat ko na lang muna, EL, 2L minus L. So that's R raised to L. 1 minus 2. That's 1. Negative 1. Okay. And then this is negative L minus 1. The other side is AL. R raised to L minus 1. Ooh. Times L. Okay. So we have AL R raised to L minus 1. Tapos negative L minus 1 minus L. Okay. So this is AL R raised to L minus 1 negative 2 L minus 1. Tama. And then, write down ko na yung mga nasa gilid. P of L cosine theta. And then the other side is, of course, ganun pa rin. Now, what you can do is, of course, try to solve AL by mathematical rigor by using the Fourier trick. Okay? Pero ang gagawin natin, syempre, sabi nga natin, mas madali dapat tong way na to. So, eyeballin na natin. Okay? Eyeballin natin. Alam natin cosine theta lang to. Okay? And anong PL yung nagbibigay ng cosine theta? P1. Okay? So, cosine theta is just P1 cosine theta. Okay? So, the first Legend. So, okay. So, the first Legend polynomial is cosine theta lang. Okay. So, that gives me that L must be equal to 1. So, lahat na mag-vanish. All ALs vanish. All AL vanish. Except for A1. Okay? So, we have A1. Must be, plug in lang natin yung 1 sa lahat ng L. Okay. Pansinin nyo, may negative to, no? Negative sign. Mas may negative sign dito. Cancel ko na yun, no? So, dali, buhay natin. Okay, R raised to L minus 1. So, that's 1 minus 1. So, R raised to 0. That's just 0. R raised to 0. I joke, R raised to 0 is equal to 1. Sorry. Then, plug in 1 here. I have 2 plus 1. 2 plus 1. And that's, cancel na natin yung negative sign. P1 cosine theta. Okay, systematically. Oops, sorry. Over. And then the equal sign P cosine theta epsilon naught. Okay, I know this guy cancels out. And A1 is just 1 P over 3 epsilon. Okay. Now I can write down my potential, of course. The potential will be this guy. Okay. So the potential is no longer a summation. So kasi 1 lang na matitira naman eh. Okay. So A1, that's P over 3 epsilon naught R raised to 1. So that's R lang. Then cosine theta. Tapos, may 1 over 4 pi epsilon naught pa rin, of course. Sorry. Okay? And then for the outside, this is inside. Okay. So outside, so B1 over R L plus 1. So that's 2. Then cosine theta. Okay. And then what is B1? Hanapin natin si B. Makita si B. Where you at, my bro? Ayan. Pala. Okay, so si B, A1 is just B1 over R3. Okay? So si B1 ay equal sa R cube ng A1. Okay. B1 ay R cube ng A1. R cube, oops, sorry. R cube A1. So ang A1 ko ay P over 3 epsilon naught. May 1 over 4 pi epsilon naught pa ba? Wala na pala, sorry. Ang ginagawa ko in life. Wala pala. Walang 1 over 4 pi epsilon naught. Dahil nag-ano nga pala tayo. Naka-incorporate na siya sa system mo kasi may epsilon naught. Natataka ako bakit doble-doble yung epsilon naught. Okay, so going back, is that what we got? Okay, so PR cos theta over 3 epsilon naught. PR cos theta. Okay, PR cos theta over 3 epsilon naught. Tapos yung denominator ay PR cube. PR cube, 3 epsilon naught, R squared cosine theta. Oh, amazing. Dali, di ba? Kaysa mag-integrate kayo. You know? I mean, ako, okay lang. Ako, mas prefer ko tong ganito. Eyeball-eyeball ka lang. Walang integration. Kanya naman ka mag-integrate, no? Wala nang problema dun. Kung batak yung minds niyo sa pag-integrate. Okay? So this is the potential. Of course, the field is what we needed with what we need to get. Okay, so ang field mo will be just the negative gradient of your potential. So dalawa yung electric field mo, inside and outside. Okay? So R cos theta is just, I can write this down as P R cos theta. Ano yung R cos theta? 3 over 3 epsilon naught. I could write this down as P tapos R vector. Okay? Tapos dotted with Z. Okay? Then, I could simply get the gradient as, double check ko lang. Tama tayo. Okay, mali pala. I mean, mali yung gusto kong gawin. Okay, R cos theta is just Z. Tama ba? P, Z. 3 epsilon naught. Tama. Tama, di ba? Yan pala yung gusto kong gawin. Pero tama rin naman yung representation kanina. Okay, so madali na lang kunin yung gradient nito. And thus, the gradient of this is simply the derivative with respect to z, of course. Okay, so the field is negative p over 3 epsilon naught z hat. Okay, so inside the material, upward, downward lang yung ano mo, yung electric field mo. So you have something like this. Pababa lang lahat ng field mo. Kasi constant siya na pababa. Okay? Amazingly. And then, yung outside the field. Outside the field. What is the outside field? Okay? Kunin na lang natin dito. Okay? Sulat na outside. What is that? Okay. PR cube. PR cube cosine theta over 3 epsilon naught or squared. Okay, I could write this down as lagay ako ng P 4 pi r cube cosine theta. And this is syempre magkakaroon din ako extra 4 pi, then 3, and then r squared. Okay, so this 4/3 pi r cube, that's your volume, times P, that's your capital P to. Okay, again, pag P is just yung dipole moment over some volume. So, minultiply mo ng volume, makukuha mo yung dipole moment. No? So, this is just 1 over 4 pi epsilon naught P. Yung small p na to, small p, dipole moment na, dotted with r hat. Okay? Para makuha yung cosine theta. And then just r squared. Okay? So, si P mo kasi ay directed upwards. So, shortcut ko na lang. And what is this? This is your field for a dipole. Nandito yun. Nakita natin yun dito kanina. Field for a dipole. Where are you? Yan. Okay? In general lang to. Pero since naka-Z naman tayo, rekta na. Okay. My point is, pag kinuha mo yung gradient nito, ba't natin sinulat na ganun? Pag kinuha mo yung gradient ng potential ng dipole, siyempre, negative gradient ng V dipole should of course be equal to your electric field of a dipole. Okay? And your electric field of a dipole, alam natin yun, given yan from last topic sa multipole expansion. So, ang itsura nun will be something like this. So, magiging dipole sa outside. Okay? So, that's why Gauss's law won't work sa configuration nito. Okay. Ay, upwards pala. Upwards. Okay? Okay. Okay. Amazing. Okay, now what we want to do. What do we want to do? Tapos na pala yung lesson. Okay, reading assignment. Siyempre, hindi kayo convinced sa mga pinagsasabi ko ngayon, di ba? So, sa Griffiths, meron siyang physical interpretation of bound charges. So, yung bound charges mo ay ito again, yung sigma B at rho B. Okay? So, kung gusto mo maintindihan palalo yun, you can read this. Okay? The field inside the dielectric, meron din siyang topic for that. Okay? Kasi parang arbitrary naman pinaggagawa natin. Sir, saan mo hinugot yung P? Okay. Okay? Pero in essence, yung field inside the dielectric can always be solved by using this guy. Okay? So, pinrove niya na ito rin yung makukuha mo. Okay, what does the bound charges mean? Okay? So, sulat tayo dito. Somewhere deep. Okay. Kuwari, meron kang cylinder. Okay? And then you polarize it in some direction along its length. Okay. So, kuwari may field ka na ganyan. So, bombard mo siya ng field. So, siyempre, ang mangyayari sa kanya, at some point, yung cylinder mo magiging polarized na rin. Okay? If you bombard it with strong electric field in one direction. Okay? So, at the back end, blue na lang. Green na lang pala. At the back end, meron kang accumulation ng negative charge. Okay? And at the front end, may accumulation ka ng positive charge. Okay? So inside, meron ka naman din na yung mga molecules mo, mag-a-align pa rin naman sila. Yan muna akong marami. Mag-a-align pa rin naman sila. Okay? Kuwari may mga molecules ka inside. Ay, hindi na pala. Okay. Yeah. So, kuwari marami tayong dumbbells inside the material. Okay? Mapansin nyo na ito magka-cancel out lang, magka-cancel out lang, magka-cancel out lang, magka-cancel out lang, magka-cancel out lang. And so on and so forth. Okay? And ang essence nun ay ito yung tinatawag natin sigma. Sigma B. Okay. So, yun lang yung simple explanation. You can always read your reading assignment in your free time. Okay? So, yun yung mangyayaring sigma B na kinukuha natin na field or potential. Okay? So, ano naman yung rho o yung bound charges na rho? So, itong rho, depende yan sa system mo. Kapag kung what, spherical system mo, say we have a yes, white na lang muna. Okay? Ang paano kapag yung polarization mo comes from the outside, ay inside, okay? Let's say, ayun yung neutral mo ngayon, neutral yun. However, if you try to place electric fields all over it, mangyayari, let's say, mag-accumulate charges mo, yung charges mo near the boundaries. And syempre, may matitira sa loob, sa center mo, center piece. Some collage of some negative values. So, meron kang some matitirang electric field that would point outside. Okay, and so on and so forth. So, madami yan. Okay? Ang point is, alam natin yung outside may sigma B. However, yung inside, kailangan din natin mabigyan ng pansin. Okay? So, itong nasa loob na yan, ayun yung dinedesignate natin na negative del dot P. Okay? Kaya divergence yung ginagamit kasi para makita mo kung pa-diverging yung system. Okay? Kaya dito, linear lang yung polarization, walang rho B kasi makukuha mo na lahat sa edges. Okay? Kaya yun nangyari kanina na walang P. Okay? Wala yung second term na dito, rho B. Okay? Amazing. So that's what happens when you polarize the material. Okay. So that's it. Or kung gusto niyo pang basahin siya, pero of course, you have the freedom to do that. Next naman, na topic natin will be the electric displacement. This is nice. Okay. Now, syempre, wala bang mas madaling way para solve itong mga bagay-bagay na to? Okay, let's do a simple way. Hindi ko pala nalagay yung example. Sige, gawin ko na lang. Okay, the electric displacement. So now let's denote rho to accommodate everything. Okay? So si rho B, you polarize na bound charges. And then plus rho F. So yung rho F will be everything else na hindi bound. Okay? Okay? So yung Gauss's law natin, del dot E, di ba na kinuha natin to from third lesson? Del dot E equal lang yung sa rho over epsilon naught. Okay? So del dot E equals sa rho over epsilon naught. Nilipat lang natin si epsilon. Okay? Tapos si rho, sulat natin siya ngayon as rho B and then rho F. Okay? We know rho B is just the negative divergence of P plus rho F. Okay? Now, I can switch. Lipat ko sila lahat doon para cute lahat ng divergence na sa kabila. So, I have epsilon naught. Let's write that down. I have epsilon naught del dot E plus del dot P. Okay? Should be all equal to oops, sobra. Rho F. Okay? Now, I can write tinatawag natin electric displacement D, which is just first vectors to mga to. Epsilon naught E plus P. Okay? So that I can now write this down as rho F. Okay, this is nice. Kasi 'di ba yung unang Gauss's law natin rho over epsilon naught. Okay? So from here, makakagawa tayo ng Gauss's law for the electric displacement. Galing, di ba? So the integral form for that is given by this. Okay? So QF enclosed. So yung mga ika-count mo lang will be the free charges that are enclosed. Okay? So let's try an example. Okay, let's try an example. Yeah, let us back on that. Okay, let's try an example. Okay, along straight wire. So let's draw a wire. Long straight wire. Of line charge lambda. So line charge lang yan, yung green natin. Is surrounded by a rubber insulation out to a radius A. Let's say ito yung rubber insulation. Okay. So ayan ay nakabalot daw sa isang rubber material. Nice. Okay? So syempre ayusin na lang natin yung drawing natin. A yan. Kuwari cylindrical yan. Cylindrical yan dapat. Pangit lang drawing ko. Okay, so find the electric displacement. Gawin lang natin to. So pipili ka ng surface. The Gaussian surface will be Pili ka ng Gaussian surface. Of course, cylindrical din. So let's pick that as D dotted with 2 pi r or 2 pi S 2 pi S L times the length kasi ayun yung cylindrical surface mo. Okay, and then I can write down yung charge enclosed ko QF enclosed of I enclosed I the line charge times the line. Okay? Fairly simple. Okay, so I now know my electric displacement, which is just lambda L over 2 pi S L S hat kasi direction ng S ito. S hat ito. So I cancel L, and my is like this. Okay? So anong sense na? Okay, ang galing dito kasi isa na lang yung kinukuha kong displacement. Di ba kasi dati sa Gauss's law dati, dalawa yung kukunin mo whenever you're inside or outside. Okay. Minsan isa na lang yung kukunin mo. Dahil tingnan natin, kapag lumabas tayo, yung free charges is still just the lambda. Okay, kahit inside ka ng rubber or outside ka ng rubber, it is the same. Okay? Okay, now what now? Siyempre, ang useful dito is yung relation ng D. Okay? Okay. So, masolve mo ngayon yung E. Okay, so D is given by epsilon naught E plus P. Okay. Outside, makukuha natin. Outside. So that is S greater than A. Okay. The field is given by, alam natin yung P mo would be 0 kasi there are no charges outside. The vacuum outside, di ba? Walang mga bound charges, walang polarized charges outside. So that is 0. Then simply have my E as D over epsilon. Very easy. And that is lambda 2 pi S. Lambda 2 pi S hat epsilon naught. Okay, dali, di ba? However, inside, can we get the field inside? Can we get the field inside? No, we can't get the field inside kasi P was not specified. Okay? Or P is not specified. Okay? So walang hindi natin ma-solve yun. Kailangan meron kang P para makuha yung load. Okay? Okay. Okay. Parang sa mga naunang lesson lang din, merong boundary conditions for your dielectric displacement. Okay? So kapag tumawid ka ng surface, the discontinuity is given by sigma F. Okay? So the free charges ay yung difference mo. Okay? So, ma-derive nyo to kapag ginamit nyo yung previous boundary conditions. And then, use this, of course. Okay? And then, yung parallel to the surface will be the difference from the above and below ng electric displacement should be equal to the difference above and below ng polarization. So, hindi pa akong bibigyan ng prob set dahil may exam na kayo para ma-explore nyo itong mga ito. Basically, again, this, guys, the boundary conditions tell you if your equations are correct. Okay? Kung tama ba yung pinagsusolve nyo. This is always true. Okay? So, that's it. That's the lesson for today. We have May 30 minutes pa tayo para makapag-discuss ng mga bagay-bagay. Okay, basically today we just touched the topic of electric fields in matter kung saan meron kang polarization. Polarization ay yung pagkakaroon mo ng dipole moment sa loob ng volume mo. So dipole per unit volume, dipole moment per unit volume, polarization mo. Okay? Then we simplified our potential as a function of the bound charges, bound surface charges, and the bound volume charges. Tapos tinry natin separation of variables for spherical as practice for exam. And then the electric displacement, which is the analog of the electric field in matter. Okay. Kapag may matter ka na, electric displacement na gagamitin mo. And then of course, correspondingly, meron kang boundary conditions for that. Okay? So we have another Gauss's law for electric displacement. Okay, that's it. That's it for the lesson today. Okay, now, exam things. Do you have any questions sa exam? Hello guys, are you there? Diyan pa ba kayo? Kung wala nang tanong, dismiss na. Okay, ilang problems yung exam? There are 6 problems in the exam. 6 problems, maraming sub-items. Ang total will be 100, pero ang given na points ay 105. So may 5 points bonus pa. Okay, so 105 over 100. Okay, what are the things na... Sige, wala na bang tanong? Dismiss na, wag na. May effort points. Siyempre, may effort points. Depende sa effort nyo, no? Kung may sense yung effort, siyempre, may bonus points. Systematic naman yung sub-items. Okay? Yung sub-items ay related to the... Walang chapter 1, yes. Kasi kukopihin nyo lang sa libro yun. Walang sense. Walang sense yung ano. Kasi pag nagbigay kami ng, kunin namin triple products nito. Okay, titingnan nyo sa chapter 1. Everything is mechanical. So walang thinking na ganap. You just mix and match things pag chapter 1. So hindi na ako nagbigay ng chapter 1. Okay, I'd like to point out sa... Okay, ito ay... Mag-share screen ulit ako. Okay. If you have a... the Poisson's equation, del Laplacian of V, negative rho over epsilon naught. Okay. Okay, so we have this, and you're given Green's function, a general Green's function. Okay, what is V? In general, what is V? Jello, what is V? How can you write V?
Hello po, sir.
Hello, hello.
Ay, hello, wait na po, sir. Medyo naguguluhan po.
Okay, sige, sige. Joshua, nandiyan ka?
Yes po, sir.
Ano yung prescription natin? Ano yung solution for V? Given si G, given si G.
Ito po ba yung parang sa separation of variables nito?
Green's function to. Ano yung prescription na sagot?
Sir, hindi ko po ma-record.
Okay, sige. Pass ba? Pass ba?
Yes po.
Okay. Di ba ang ginawa natin sa... Sige, balikan natin. May gains function naman tayong lesson. Okay, so whenever you have u here, ito, kita niya. Whenever have u and some differential equation, okay, na sulat mo ngayon as L, and you have G, you solve for G. Now, the prescription, the solution for this guy, okay, for this guy. So, titingnan natin ano yung itsura niya dito. Ay, lumipat. Okay. Now, I can write this as L. Oops. What's happening? Yung del squared ko, i-Laplacian ko, pwede isulat niya as L, di ba? LV negative rho over epsilon naught. Okay. Titingnan nyo lang ngayon. I-mix and match nyo lang. Okay? So, yung V doon kanina, U dito ngayon. Tapos yung nasa right-hand side, whatever that is. Sulat mo na lang siya as F. The prescription for the solution for U is just the integral of your Green's function times the right-hand side. Okay? Okay, malinaw ba yan, guys? So, may Green's function sa exam, no? Malaki-laking points siya. 20 points. 20 points ba? 20 points. So, kailangan ko siya ibigyan kayo ng heads up. Okay, so anong solution? Ross, anong solution dapat?
Sir, integral po ng Green's function.
Okay.
Negative rho over epsilon naught.
Okay, very good. Okay. Integral with respect to, this is R prime. This is d tau. Okay. Okay. Now, meron kasing, look at this. I could always write, di ba, del squared ng V is equal to some function. Sulat na lang natin as function. Some function f, di ba? Now, I could write V as V naught plus V prime na pala. I can write V prime as some function of V and some V naught. Okay? And now, the Laplacian of V prime is just the Laplacian of these two. So, V plus V naught. I know yung Laplacian ni V. Alam ko yan. Yung Laplacian ni V naught. Don't know. Yung Laplacian ni V naught will be some F. Di ba? Ito yun. And then if this is 0, then I could always solve for a function V prime as some F. Okay, anong point ko? So, ang point ko is, in general, you have this guy. The general solution would be, of course, the integral of some Green's function, R prime. Then, yung right-hand side, integrated over the volume. Then, you have some plus, okay? And some integral of the Green's function times something. Times something over the area. Okay? In general, may extra term na nilalagay. Kasi nga, pwede tayong mag-solve ng ganito. Pwede tayo magdagdag ng potential, na adjustment na potential. Okay? So you need to find out what is this, the general form, the whole. Okay? Okay? So you try to explore books bukas. Try nyo explore si Jackson, Electrodynamics. Okay? To find out what this guy is. May F din yun. In terms of F din to. Pero what is there? Okay? Okay. So that's your clue for tomorrow. Okay, what else? Okay, may mga tanong pa ba? Kung wala nang tanong, kaya nyo na exam. Mag-consult kayo habang may oras, no? Baka hindi na tayo mag-review bukas kasi madali lang. Madali yung math, pero confusing siya. Okay, so if tomorrow may ginagawa kayong hardcore things, baka mali yung ginagawa niyo. Okay, questions about exam. Sige, go. Need namin pag-aralan. Electric field, work and energy and electrostatics. Chapter 3, lahat yun. Except multipole expansion. Bali yung multipole expansion, ginawa na lang Green's function. Okay. So may method of images, merong separation of variables, then the Green's function. That's for chapter 3. For chapter 2, hindi ako nagbigay ng capacitor problem. Okay? For chapter 2, yun yung mga sinabi ko, electric field, force, potential. Okay? Potential, yun po ba? Conductors. Mahalaga yung conductors. Okay. Very confusing sa conductors, ha? Yung mga properties ng conductors. Okay, ano pa ba? Pag nag-drawing kayo bukas, sige, may drawing kayo bukas. So, drawing kayo ng mga bagay-bagay para may points kayo, di ba? Okay, so, nakikita na ba? Pag nag-drawing kayo, lalagyan nyo dapat ng kita na ba? Sorry, naglalag ata yung internet ko. Thumbs up kayo pagkita. Okay, thank you. Okay, so pag nag-drawing kayo bukas, nag-drawing kayo, may spherical problem. Okay, kuwari ganyan. Hindi kayo pupulis yung drawing nyo. Pangit din naman ako mag-drawing. Okay. Yan, spherical kunyari. Siyempre, lalagyan nyo dapat ng axis, di ba? Para naman nagkakaintindihan tayo. So, mas maganda rin na i-color code. Yes. Okay. Mas maganda rin na i-color code yung system nyo para din mas madali namin tignan. Okay. So, lalagyan nyo dapat ng label. Y hat. Z hat. Okay. Tapos, anong radius nito? Anong radius nito? Anong radius nito? Okay. Well, kung spherical naman, syempre madali na lang yung ganun. Isa na lang yung alin yung mga angles mo, etc. You have to label things. Okay? May drawing lang kayo below. Tapos, ang gagawin ko dyan? Di ba? Kung walang coordinate system. Okay? Okay. Required ba yung drawing, sir? May tanong na may drawing. Ayun yung point ko. Okay. May 5 points. Draw the system. Ganun. Bali, naka-paragraph form lang ibibigay sa inyong tanong sa iba dun. Okay. Draw the system. May points na agad kayo, di ba? Nice. So, maraming sub-steps. Di ba? May 6 kayo na. May 6 na tanong. So, sa kada tanong, maraming sub na steps. Pare, number 1, may A to E. Ganun. Sa A, draw the system. Yan. Second one, etc., etc. Okay? So, what else? Sige, questions pa. Okay. Kung wala na, sige, dismiss na. Good luck sa exam tomorrow. Ayan, may question. Sir, may problems po ba na specified yung method na gagamitin like bawal, Gauss's law, etc.? Wala. I mean, if you can get the electric field, then get it. Okay? Ano passing? Ano passing dito? Ano passing pag physics? Okay. Ang daming tanong bigla. Ayos to, ayos to. Doon lang sa may tanong dito kanina. Yung tanong kanina ay may problems po ba na specified yung method na gagamitin like bawal mag-Gauss's law, etc. Okay. Merong items na prescribed yung gagawin mo. Okay? So, if yung tanong ay pinapagawa sa'yo na separation of variables ka, then you have to do the separation of variables. If walang specified, edi ikaw bahala sa buhay mo kung gusto mo gawin. Paano malalaman, sir, na pwede i-apply yung azimuthal symmetry for 2D spherical? Okay. Malalaman mo siya kapag walang phi dependence or basta two variable dependent lang yung mga given sa'yo. Yung charge distribution, kunwari, with respect to theta lang. Okay? That applies for azimuthal symmetry. Anong po passing, sir? Di ko alam, 50% ba? 20%. 50% ata passing. Ilang hours po doable yung exam? 2 hours. Siyempre, 2 hours pag kami. Siyempre, maayos na solution na. Yung systematic solution na sulatan nyo lang bombard nyo lang yung papel nyo ng mga equations. Siyempre, mamalian namin mga ganun. Systematic dapat yung equations. So, 2 hours. And then, kung sa inyo, multiply natin ng 3. So, 6 hours. Actually, madali eh. Madali exam. Subset sir na ganun. Okay. Parang prob set, sir, na ganun ka-detail. Yung sa inyo, yung iba sa inyo, pag nag-prob set, kuwari Gauss law prob set, yung grabe yung ginawa yung explanation doon. Guys, okay na, alam na natin yung volume ng cylinder. Hindi nyo na kailangan integrate pa. Okay? Hindi nyo na kailangan integrate yung sphere kasi alam na, it's common knowledge yung sa ating mga applied physics major kung ano yung volume ng sphere. Okay? So, no need pag mga ganung bagay. Okay. Okay, what else? So, in essence, parang ganun baka detail. Well, dapat kasi ganun ka normal yun. Ganun normally dapat yung ginagawa niyo. Na nagsusulat kayo ng supporting statements kung bakit nyo ginagawa yung mga bagay. Okay? Okay? So what else? What else? May tanong pa ba? Tanong nyo na lahat ng dapat nyo itanong. Again, sabi ko nga, madali mathematically yung gagawin nyo bukas. Mas mahirap yung mga prob set ko. Okay? But conceptually, doon lang. Doon kayo balito. Confusing siya in terms of geometry. Okay? Pero may mga bonus na item, no? Bonus. Parang sinolve na natin in class. Okay, may mga ganong tanong. Okay, what else? Kung wala na, sige, dismiss na kung wala na. Wala na itong tanong. Sa exam, kahit ano lang, no, phrases lang na, okay, this is blah, blah, blah. Okay, no need na kuhain nga. Yung mga bagay na alam naman na natin, wag nyo nang i-detail out. The volume for a sphere. Gulat ako sa Gauss's law, yung daming integral. Okay? Nag-upload na ako ng mga solution na sa ProbSet. Yung isa na lang hindi pa. Upload ko mamaya. Try ko mamaya. Okay? So, kung wala na, class is dismissed. Thank you for attending the synchronous session.